So our first question, um, the USS Ohio has just left for deployment. The crew is floating on Puget Sound. Once they leave the sound, they want to submerge. And by doing this, they open ballast tanks on the side that will fill with water. Describe the opening, how the opening allows the ship to submerge. I said opening will cause water to flow into the tanks. The additional water will increase the mass of the ship. This added mass will create a larger weight force, and this weight force will overcome the buoyancy force as the submarine won't displace enough water to keep the submarine afloat. The second question states the submarine floats while on Puget Sound. The submarine has a length of 170 meters and a diameter of 14 meters. What would the mass of the submarine be? Our knowns, length is 170 meters, diameter is 14 meters. We are finding the mass. We can assume only two forces are acting on the submarine, the weight force and the buoyancy force. We're assuming no acceleration in the y direction, so it's not accelerating up or down. And we're saying only the spotting tower is out of the water, so this means that the entire diameter will be submerged. Properties, gravity 9.81 meters per second squared, and the density of water we're saying is 1,000 kilograms per meters cubed. It may be a little bit higher due to the water being seawater with salt in it. But for solving, our weight force is equal to the buoyancy force. We further expand upon that. mg is equal to rho vg. Get rid of the gravity constants. Mass is equal to rho v. We find our v with v equaling 2 pi rl, and that equals 7,477 meters cubed. And that will be our final answer, 7,477 metric tons. This final question states the submarine sinks to a depth of 400 meters below the surface of the water. How much pressure will be exerted on the submarine at this depth? We know the height will equal 400 meters. The pressure is what we're finding. We can assume P atmosphere is around 101 kPa. Properties, gravity is 9.81. Density is 1,000 kilograms per meters cubed again. To solve simple hydrostatics problem, P is equal to P atmosphere plus rho GH. And then we put in our P atmosphere plus our rho G and then H of 400, and all divided by 1,000 as we convert from pascals to kPa for a final answer of 4,025 kPa.